when we got into engineering notation, I sensed there was a little bit of confusion. The big thing is it seems unnatural at first. What we're trying to do is any big number or small number that we have, we're trying to reduce it into something that begins with the number 1, 2, 3, etc. up to 999. So it must be a 1 through a 999. It can't be over 1,000, it can't be less than 1. So that's the first part. And then it's times 10 to the, it has to be some multiple of 3. And that seemed like, what? So that exponent must be a 3, a 6, a 9, a 12, a 15, and so on. But why would we do that? Well, you have to remember that these multiples of 3 actually relate to our metric prefixes. Things like kilo, it's 10 to the 3, mega, 10 to the 6, giga, 10 to the 9, tera, 10 to the 12, milli, 10 to the minus 3, micro, 10 to the minus 6, nano, 10 to the minus 9, pico, 10 to the minus 12. So by using these in engineering notation, now we can get expressions like 13 kilowatts, which is 13 times 10 to the 3 watts, which is 13,000 watts. Or going the other way, we take 13 watts and express it going backwards as 13 times 10 to the 3 watts, or 13 kilowatts. Next one, if we had 192 million watts, what we're saying is 192 times 10 to the 6. Notice that the number I chose here was not 19.2, it was not 1.92, it was 192, which is between 1 and 999. And we have a power of 3, 6, 9, 12, 15, whatever. It must be a multiple of 3. So I've got my multiple of 3, my number between 1 and 999, 10 to the 6th is mega. So 192 million watts becomes 192 times 10 to the 6 watts becomes 192 megawatts. It also works for small numbers. 0.074 amps. Well, I need to make a number between 1 and 999. Out of here I see 74. And then I have to multiply that by 10 to the factor of 3. Here I've got 74 times 10 to, sorry, not factor, multiple, times 10 to the minus 3. Which leaves me with 74 milliamps, because 10 to the minus 3 is million. So I took my 0.074 amps and made it into 74 milliamps. This is why we use engineering notation.